Hello everybody and welcome to the next episode. Let's start. Today I will show you how to handle press fits methods in Abaqus Standard. There are several options to define press fits. Press fits are usually defined as a tolerance between two parts. It can also be a kind of clamping to fixed parts with frictions. Press fits are generally called engineering fits and can be described as a shaft and hole pairing. In general words, press fits determine the clearance or interference between two parts. The property of an interference describes a penetration between two bodies. It is resolved in the first step and results in stress and strain in a model. It is not a strain-free adjustment to get an initial clearance of zero. The solving of an interference step in Abaqus Standard is shown in the next pictures. It begins with a given interference, the solver solves the contact problem, and at the end the contact has no interference and results in stress and strain. There are two possibilities to solve an interference problem. The first is to define an interference independent from the geometry. It can be used for tolerance studies and it's easy to change. The second possibility is an automatic shrink option. It is used to real geometry, but sometimes it has some convergence problems. The definition of an interference can activate in the keyword contact interference with some additional parameters. The option shrink is used for a real geometric interference fit. Two keyword examples for the contact controls give you a short overview. The first example defines an interference fit over 0.2 mm. The value must be negative. The second example shows the option shrink for a real geometric interference. An example with a bearing in the plate shows the use of an interference. The plate is fixed at the side and the bearing is fit in the hole of the plate. In this case there is no interference. So the stress and strains are zero, as you see here. In the next example, an interference with 0.2 mm for an interference fit was defined. The initial real geometry has no interference, but after the interference step, the contact shows a gap over 2.02 mm. In CIE, the value for interference fit is defined in the menu for interaction with the magnitude and amplitude. The keywords in the input deck needs the contact pair definition and contact interference, as shown here. It uses an amplitude and a negative value for interference. If the value for the interference is negative, then it defines a press fit. For a positive value is defined a clearance. The amplitude is required to define a contact close at the end to the end of the step. The calculation shows over 2000 megapascal at the end of the step. The result at the end shows a visual gap in amount of 0.2 mm as you see here. The next example uses a real geometric press fits between bearing and plate. The initial real geometry has an interference in amount of 0.2 mm. After the interference step, the contact is closed without gap. In CIE, the shrink option is for interference fit is defined in the menu for interactions. The keywords in the input deck needs the contact pair definition and contact interference, only with the shrink option, as shown here. The calculation shows stresses over 2000 megapascal at the end of the step, similar to the previous example. The result at the end shows no gap and the contact is closed, as you see here. At last, the conclusion. An interference step is almost the first step. The interference fit can be defined without geometric dependencies. Geometric interference fit can be solved with the shrink options. Thank you for watching.